Hi, my name is Ale, and in this video we will be building a simple weather app that shows the weather in your current location. We're going to follow a model view model architectural pattern, and we will be using the OpenWeatherMap API to get the weather data. Before we start building the app, we need to create an account in OpenWeatherMap and obtain an API key. You can do this by going to openweathermap.org and then clicking on API and then on sign up. So you will fill out all this information, and once you log in, you will be able to create an API key. Once you're logged in, you can click on the API keys tab. Then we can create a key. So we have to provide a key name. We can call this SwiftUI weather app, and then you can click on generate, and you'll see that you have a new key that is created. We'll be using this key when making requests to get data from OpenWeatherMap. Like I mentioned earlier, we will be using the MVVM or Model View Model architecture. With this architecture, we have three main components. We have the model, and the model is completely independent from the user interface. It handles any data and logic that powers our app. And when the model notices a change, it will notify our view model that will be responsible for reflecting any changes on the screen. Then we have the view, and the view consists of the visual interface of our app, so everything that the user will see on the screen. Whenever a user action occurs on our view, it will notify the view model so that this action can be handled. Finally, we have the view model, which sits between the model and the view. We can think of the view model as an interpreter. Our view model is bound to our view, and whenever the view model is notified of a model change, the UI in our view will be updated. The view model will also be notified of any user action on the view and will subsequently modify the model, and then our cycle starts again. Now that we have created our API key, we can navigate to the API page, and there are different types of data that we can get. We're going to be working with the current weather data, so let's look at the doc. As you can see, there are different ways to get the weather data, and we're going to obtain it by using coordinates, so latitude and longitude. And these are the different parameters that you can pass into a request. Now let's take a look at the response that we will get from OpenWeatherMap. We'll be using the JSON format, and as you can see, we get a JSON dictionary with all the data that we'll need. So in our case, we're going to be using the name parameter, which will tell us the name of the city. We'll also be using the main parameter, as here we will be able to get the temperature. And finally, we'll be using the weather parameter, since we'll be getting here the description of the weather, as well as an icon that we'll be able to use to display on our app. Now let's go back to xcode to start building our app. We're going to add a new file called weather service, and here we will get the user's location and then get the weather from OpenWeatherMap. So let's go ahead and add this file. Let's first add three different structures that will represent the response obtained from the OpenWeatherMap API. So if we look at the response again, we'll be using this weather dictionary, which contains 4 different key value pairs, but we'll only be using the main value as well as the description value. So in xcode, we'll create struct API weather, which is decodable. We'll have a description, let description, which is a string, and then we'll have an icon name, which is also a string. Now, if we go back to the API, we see that we have the description key value pair, but we don't have an icon name key value pair, and that's because we'll be using the value of this main dictionary to get the icon. So what we'll do is we'll create a coding key to tell Swift that instead of using icon name as the key, we'll be using main as the key to obtain the value. So if we go back to xcode, inside the API weather struct, we can declare an enum called coding keys, which is a string and a coding key. And we have two cases, the case description. In this case, we want to use that same name as the key, so description is the key. But for the case of icon name, we should be using main as the key in the dictionary. And that means we'll be able to get this value here using the key main. Now let's add another structure, which is the API main structure, struct API main, which is decodable. And from this structure, we will be getting the temperature, which is a double. So if we go back to the API response, we see in this main dictionary, temperature has a key of temp and a type of double. So in xcode, we'll add let temp, which is of type double. Now finally, we're going to add a structure to represent the whole response that we get from OpenWeatherMap. So let's add another struct. We'll call this API response. And inside this API response, we're first going to have a string, which is called name. And like we saw earlier, this will give us the name of the city that we're getting the weather for. And then finally, we're going to add two more properties to this structure. One that will be this main dictionary, and the other which will be this weather list. As you can see, this is a list which has a dictionary inside. So if we go back to xcode, we'll have the main dictionary, let main of type API main, and then let weather, which is a list of the API weather structure. Now that we have the three structures that represent the JSON response that we get from OpenWeatherMap, we're going to define a new class called weather service. So let's add public final class weather service, which is a subclass of NS object. Let's also add an import statement to import CoreLocation. This will let us use the library that will allow us to obtain the user's location. And now let's add three properties inside our weather service class. So first we'll need a location manager, private let location manager, which is a CL location manager. Then we'll define a constant to hold our API key. So let's go back to the OpenWeatherMap API, and we can go to our API keys. So we define this SwiftUI weather app key. So you can copy and paste yours. And we'll create private let API underscore key, and we'll create a string with this key. And finally, we will have a completion handler that will be executed when we're able to get the weather data. So private var completion handler, which is of a function. For now, this function will take in no value or no parameter, and it will also return no value. And this is an optional property. We will be modifying this completion handler later on so that it will be able to get some weather data and provide it to our view model. Before we continue writing the code in weather service, we're going to do two things. First, we're going to go to our info.plist, and we need to add a new property to let xcode know that we will be using the user's location to get the weather data. So we can click on the plus sign and we can look for privacy dash location, and we're only going to need it when the app is in use, so we can select location when in usage description. And for the value, we can add a string. This app requires your location to provide weather data. Perfect, so now we'll be able to get the user's location in our app. Now we're going to add another file to our project, and this will be our model. So let's create a new file, and this will be called weather. Inside this class, we'll hold the model data that our view model will use to show in our UI. So let's define a structure, public struct weather. And our weather struct has 4 properties. First, it will have a property called city, which is a string. Then it will have the temperature, which will also be a string. Then we'll have the description. And finally, we'll have the icon name. Now, to initialize a weather model, we'll need to have our response as a parameter. Response, this will be an API response. And from here, we'll be able to get the data we need to populate these 4 values. So first, we'll populate the city. City is equal to response.name. Then the temperature will be equal to, we'll convert the double to an int. So int response.main.temp. Then the description, we'll be able to get it from response.weather, and remember this weather is a list. So let's try to get the first element in this list, and we'll get the description. Since this is optional, we'll have to provide a default value, which will be just an empty string. And finally, we'll get the icon name. And we'll be doing something very similar to the description. This will be response.weather.first.icon_name. If it's not available, then we'll provide an empty string. Great, so now that we have our model class, let's go back to our weather service. And like I mentioned earlier, we're going to modify our completion handler so that when this function is called, we'll provide a weather object. And now we're going to create different functions that we'll use to first get the user's location and then get the weather data from OpenWeatherMap. So first, let's add a function, public func. We'll call this load weather data, and it will have as its parameter a completion handler, which will be a function that takes in a weather object and returns no value. And here we'll have to add the escaping property. Okay. So here what we'll do is assign the completion handler. Then we'll ask our location manager to request the user's location, request when in use authorization. And after that, we'll ask the location manager to start updating the location. So now let's add another method, and this method will be called makeDataRequest, private func makeDataRequest, and this will be for coordinates, which is a CL location coordinate 2D. In this method, what we'll do is we'll send a request to OpenWeatherMap using these coordinates as well as using our API key to get the weather data for this location. So if we go back to the API, we can see that this is the format to make an API call. We'll need the latitude, the longitude, our API key, and we can also provide other values like units and language. So let's actually copy this URL as it will be helpful for creating our own URL inside our app. Okay, so let's first create a string of our URL. So let's do cart let URL string be equal to, let's copy this. So for the latitude parameter, we're going to replace this and we'll get the coordinate latitude. Then for the longitude parameter, we can also replace this and get the coordinates longitude. Then for the app ID parameter, we can use our API key. And finally, I'm going to add the units parameters because I want to get the weather in Celsius, so we'll use metrics. So we add and units equal to metric. Now we'll also want to add a percent encoding, and the character set will be URL query allowed. So if we're not able to build this string, we just want to return. Cool. Now that we have our URL string, then we can create the URL. So let's add guard let URL be equal to URL from a string, which is our URL string, else return. Now, if we're able to create this URL, then we'll use URL session to send our request. URL session dot share dot data task, and we'll provide a URL, and we also want to have a completion handler. So we'll pass URL as the parameter, and for the completion handler, we'll get data, response, and error. Data, response, error, in. So first we'll check that the error is nil. Guard error equals nil. That means that our request went through. And let's also make sure that we were able to get the data. So let data be equal to data. Otherwise, we just want to return. Now, if we're able to get this data, then we want to try and decode it because it's in the JSON format. So we'll be able to decode this and then create a weather object that we will provide to our completion handler. So let's try and decode this using a JSON decoder. If let response be equal to try question mark JSON decoder dot decode from so the type is API response dot self, and we'll get this from the data. As you can see, we have an error here because our API response is not decodable. So all we have to do is add the decodable protocol to our API response struct. And now our JSON decoder should work. So now what we'll do is, if we're able to get this response, then we will call our completion handler. And since this is optional, we have to add a question mark And in the completion handler, we have to provide a weather object. And remember, a weather object needs the response to populate its properties. Perfect. So now that we have our data task, all we have to do is call resume. Before we continue to work on our weather service to get the user's location, let's actually start doing some work on our UI. So let's go to this content view file, and we'll actually be renaming this file to weather view. We'll also rename the struct to weather view. We'll have to make sure to update every place where content view was previously used. So that's in the preview as well as in the weather app file. And now inside weather view, we're going to add some views to display the weather. So let's get rid of this text and let's add a vertical stack or VStack. Inside this VStack, we're going to add 4 different text elements. So first, text, which will include the city name. For now, we can just add a placeholder. So for example, we can add Los Angeles. And we'll make the font to be large title. Then we'll add some padding around this text. And then we'll add another text element that will show the temperature. So let's add text and we'll use a placeholder. So for example, we can add 25 degrees Celsius. And here we'll make the font to be a system font with a size of 70. We'll also make this text bold. Then we'll add another text, and this will include the weather icon. So let's just add a placeholder. And we can use font of large title. And we'll also add some padding around this text. And finally, we'll have a text element to show the description. So, for example, we can write clear sky. Now, these are placeholders, but eventually we'll replace them with the values that we get from our view model. But let's run our app to see how it will look when we actually get data from OpenWeatherMap. Great, so as you can see, we'll have the city name, the temperature, an icon, and a short description of the weather. Again, this is just some dummy data, but now we're going to go back to our weather service class and get the user's location to be able to get the actual weather from our API. So let's go back to Xcode and let's open our weather service class. What we'll have to do now is implement the CoreLocation manager delegate so that we're able to get the user's location when we call this start updating location method. So let's add an initializer to our weather service class, public override init. We'll call super.init. And we'll assign the location manager's delegate to be equal to self. So location manager dot delegate equal self. Now to actually implement this protocol, we have to implement the CoreLocation manager delegate. So let's go down and add an extension to our weather service that implements the CoreLocation manager delegate. We'll be implementing 2 different methods. The first method that we will implement is the method that is called when the user's location is updated. So public func location manager here we have a manager, CL location manager, did update locations, which is an array or a list of CL location. In this method, what we'll do is try to get the first location inside this list, and if we're able to get it, then we'll send a request using the makeDataRequest method. So guard let location be equal to locations.first, else we'll return. Now, if we're able to get the location, we will call makeDataRequest, and this needs the coordinates parameter. So for coordinates, location.coordinate. Great. We'll have to implement one more method, public func location manager which is a CL location manager, and did fail with error, which is of type error. So if something went wrong, this method will be called, and for now all we'll do is print the description of this error. So print something went wrong, and we'll use the error dot localized description. Great. So as you can see in the did update locations method, what we do is first get one of the locations and then call the makeDataRequest method. And what that will do then is send the request to OpenWeatherMap. And if the request goes well, then we'll call our completion handler with a weather model object. So now that we've defined our weather service and we also have our weather model and our weather view, we're going to create our weather view model. So let's go ahead and add a new file. We can call this weather view model. And in this file, what we'll do is get the data from our service and convert the model to the information that our view needs to display in the app. So let's define a class, public class, weather view model. And our weather view model will be observed by our view. So we have to make sure that this is an observable object. Our view model will have 4 properties that will be published. So that means that whenever these properties change, our view will update accordingly. Add published var city name, which is a string, and initially it will have the value city name. Then we'll have another published variable, add published var temperature, which will be a string, and initially it will just be 2 dashes. Then we'll have add published var weather description, which is also a string, and again we'll start out as 2 dashes. And finally we'll have the weather icon, add published var weather icon, which is a string, and initially this will just be a default icon. So I'm gonna copy and paste some emoji So our weather icon initially will be this default icon, and when we actually get data from the API, we'll be able to use some of these different emoji depending on what icon name we get. So now we'll also need a weather service inside our view model, which we will use to get the weather data. So public let weather service, which is of type weather service. And we will get this weather service when our view model is initialized. So public init, and we'll need the weather service. And in this initializer, all we'll do is assign the weather service property. Now, finally, in our view model, we will have a method called refresh, public func refresh, and all this function will do is call the weather service method to load the weather data. And once this data is obtained, the view model will update these 4 published properties that the view will use to display in our app. So weather service dot load weather data, and the completion handler will get a weather model, weather in. What we'll do here is update the properties. So now, since these properties will affect the UI, we have to make sure that they're updated in the main queue. So we'll need the dispatch queue.main.async. And here we'll assign first the city name. So self.cityname will be equal to weather.city. Then self.temperature will be equal to a string that we will use the weather dot temperature, and we will also add the degrees and a C for Celsius since we're using metric units. Then we'll assign the description. Self.weather description will be equal to weather.description, and we'll make sure that this is capitalized. And finally, we'll assign the weather icon. So self.weather icon, and this will be equal to the value in the icon map that corresponds to the weather icon name. Now, since this will be optional, we have to provide a default value. So if the icon is not in our icon map, then we'll provide the default icon. Great, so now that we have our view model, we need to bind it to our view so that our view is updated whenever these values in the view model change. So let's go back to our weather view file, and here we're first going to add a property to our weather view. So we will add an observed property. Remember, we're observing the view model. So add observed object var view model, which is of type weather view model. Now, from this view model, we'll obtain the information we need to display in our text. So we can now get rid of this dummy data that we added. So instead of Los Angeles, we'll add view model dot city name. Then instead of this 25 degrees Celsius, we'll have view model dot temperature. Instead of this emoji, we'll have view model dot weather icon. And instead of clear sky, we'll have view model dot weather description. Now, finally, we want to make sure that our view model is refreshed when our view appears. So we'll use the onAppear modifier. and here we're going to perform view model dot refresh. Great, so now we have the view model as part of our weather view. So now what we'll need to do is update every place where we're creating a weather view to provide a view model. So we'll update the preview to take in a view model. So view model, weather view model. And remember, the view model needs a weather service. So weather service, and we can create a new weather service. And let's update the weather app. So let's define a weather service. Let weather service be equal to weather service. And let's define our view model. Let view model be equal to weather view model, which will need this weather service. And now we can update our weather view with the view model parameter. Great, so now that our view has a view model that will give it the necessary data to display in our app, we can run our app and see if we're able to get the weather for the user's location. Since we're using the simulator, we have to let the simulator know which location we want to simulate. To do that, we can press Command Shift comma, and this will open the scheme editor. So we can select Run, and then we can go to the Options tab. And here you can select a location to simulate. So let's select London, for example. And then we can close this. Now let's run our app. Great, so as you can see on the simulator, we now see London as the city with its weather. So it's currently 10 degrees Celsius. And the icon is a cloud. And the description is overcast clouds. And on Xcode, we also have this location button that you can press to change the location that is being simulated. So for example, let's say I select Sydney. If we go back to the simulator, you see that the weather is updated. So Sydney's a bit warmer than London. It's 26 degrees. And we can change the location to any place we want to display, and it should correctly update in our app. Great, so that's all I wanted to show you in this tutorial. I hope you enjoyed it and you learned something new. If you want to learn more about iOS development with Swift and SwiftUI, let me know in the comments, and make sure to subscribe as I'll be posting new videos very soon.